The Caterpillar Tractor Company, officially born from the 1925 merger of the Holt Manufacturing Company and the C.L. Best Tractor Company in Stockton, California, represents one of the most consequential industrial consolidations in American history. Before the merger, both Benjamin Holt and Daniel Best had spent decades competing in the agricultural machinery market of the West Coast, each developing their own versions of the track-type tractor that would become the foundation of the modern earth-moving industry. Holt pioneered the continuous track mechanism as early as 1904, replacing the massive steam traction engines that routinely sunk into the soft soil of the San Joaquin Valley. The name Caterpillar itself was born from a photographer's observation that Holt's track machine moved like a caterpillar, and Holt registered the term as a trademark in 1910. The merger was driven by necessity. World War I had exhausted Holt's production capacity, while Best had captured market share with superior engineering, and the post-war agricultural recession made consolidation the only rational path forward. The company they created would not merely sell tractors, but would fundamentally define the physical infrastructure of the modern world. The track-type tractor was not an invention that emerged from a single moment of genius, but rather a methodical response to a specific engineering problem. The California soil was too soft for wheeled steam traction engines, which sank under their own weight during the harvest season. Benjamin Holt's solution was conceptually simple, but mechanically audacious. Replace the wheels with a continuous belt of wooden slats linked together by steel chains, distributing the machine's weight across a far larger surface area. On Thanksgiving Day 1904, Holt's first successful tracked tractor crawled across the fields of Stockton, and the age of mechanized earth-moving had begun. This machine reduced soil compaction, increased traction by an order of magnitude, and allowed farming operations to proceed regardless of weather conditions. The implications extended far beyond agriculture. The same principle that kept a tractor from sinking into mud would prove indispensable for moving earth on the battlefields of Europe and the construction sites of America's growing cities. Holt's track design was a fundamental breakthrough in applied physics, and it established the technological lineage that Caterpillar would refine for the next century. Caterpillar's contribution to the Allied victory in World War II was considerable, and it accelerated the company's evolution from a regional manufacturer into a global industrial force. The company produced bulldozers, tractor scrapers, motor graders, and generator sets for the U.S. military and its allies, but its most significant contribution was the development of the D8 tractor, a machine that became the standard for military earth-moving operations in every theater of the war. The D8 was used to build airfields on Pacific islands, clear landing zones in Normandy, construct roads through the Burmese jungle, and maintain supply routes across the Russian steppes. It has become a staple of historical accounts that the bulldozer was among the most decisive machines of the war, often listed alongside the aeroplane, the tank, and the landing craft, though the specific attribution of this ranking to General George Marshall cannot be verified from primary sources and appears to be a corporate legend that has been repeated without documentary evidence. Caterpillar engines also powered landing craft, tanks, and auxiliary generators, making the company an integral component of the American war production system. The wartime experience taught Caterpillar to manufacture at massive scale, maintain quality under impossible deadlines, and support equipment in the most hostile environments on Earth. The C.L. Best Tractor Company, led by Daniel Best's son Clarence Leo Best, approached tracked tractor engineering from a different direction, focusing on reliability, operator comfort, and mechanical refinement. The C.L. Best 60 track layer, introduced in 1919, was a 60-horsepower machine that weighed over 20,000 pounds and featured a 4-cylinder overhead valve gasoline engine, a significant step forward from the crude steam-powered behemoths of the previous decade. Clarence Best understood that the market was shifting from agricultural customers to construction contractors, road builders, and forestry operators, and he engineered his machines accordingly. His tractors featured enclosed drivetrains, better cooling systems, and more comfortable operator positions, improvements that seemed minor individually but collectively represented a professionalization of heavy equipment design. When the merger with Holt was finalized in 1925, the combined entity inherited the best engineering DNA from both lineages, and the C.L. Best 60 was rebranded as the Caterpillar 60, a machine that would remain in production for 12 years and sell nearly 19,000 units. The 60 became the template for everything that followed. The company's relocation of its primary manufacturing operations to East Peoria, Illinois in the late 1920s was a strategic decision rooted in logistics, labor, and material access. Illinois offered proximity to the steel mills of Pittsburgh and Gary, the coal fields of the Midwest, and the Mississippi River transportation network that could move finished machines to every corner of the continent. The East Peoria plant would become the epicenter of Caterpillar's production for decades, employing tens of thousands of workers and generating a regional economy that was almost entirely dependent on the fortunes of the company. This concentration of manufacturing capacity created a unique industrial culture in central Illinois, where generations of families worked on the same assembly lines, building machines that would be shipped to every continent. The physical scale of the East Peoria facility was staggering, encompassing foundries, forging presses, engine assembly lines, and final machine assembly buildings that covered hundreds of acres. It was a city within a city, producing the iron backbone of American infrastructure. The Great Depression, which destroyed so many American manufacturers, paradoxically strengthened Caterpillar's position in the heavy equipment market. The company's machines were essential to the massive public works projects of the New Deal era, including the construction of the Hoover Dam, the Grand Coulee Dam, and countless other federal infrastructure initiatives that required the movement of unprecedented volumes of earth. The Hoover Dam alone required the excavation of over 3 million cubic yards of rock and soil, a task that would have been impossibly slow with steam shovels and horse-drawn carts. Caterpillar's diesel-powered tractors and earth-moving equipment proved faster, more reliable, and more economical than any alternative, and the company's reputation as the indispensable partner of American infrastructure development was cemented during these years. By the end of the 1930s, Caterpillar had established a dealer network that covered the entire United States, a distribution system that would become one of the company's most durable competitive advantages. The dealers were not merely sales outlets, but fully integrated service centers capable of repairing machines in the field. The post-war period was the golden age of American infrastructure, and Caterpillar was perfectly positioned to supply the machinery required to build the modern United States. The Federal Aid Highway Act of 1956, signed by President Dwight D. Eisenhower, authorized the construction of the Interstate Highway System, a 41,000-mile network of divided highways that would require the excavation and movement of billions of cubic yards of earth over 3 decades. Caterpillar's scrapers, bulldozers, graders, and compactors were the primary tools of this transformation, and the company's yellow machines became a ubiquitous presence on construction sites from coast to coast. The interstate system was the largest public works project in human history up to that point, and Caterpillar supplied the muscle that made it possible. Beyond highways, the company's equipment was used to build airports, dams, ports, pipelines, suburban developments, and the entire physical framework of post-war American prosperity. The company's growth during this period was exponential, with revenues increasing from roughly $200 million in 1950 by over $1.5 billion by 1970. Caterpillar's approach to international expansion during the 1950s and 60s was methodical and long-term, reflecting a corporate philosophy that prioritized dealer relationships and customer support over short-term market share. The company established manufacturing operations in the United Kingdom, Brazil, Australia, Japan, and Belgium, creating a global production network that could serve local markets while maintaining the quality standards of the American parent. The dealer network was extended to cover every continent, and the company invested heavily in parts distribution, service training, and customer financing. This global infrastructure became one of Caterpillar's most durable competitive advantages, as no competitor could match the depth of support that Caterpillar dealers could provide in remote mining operations in Chile or construction sites in Indonesia. By 1970, Caterpillar was generating more than half of its revenue outside the United States, making it one of the first American industrial companies to achieve genuine global reach. The company's yellow machines had become a symbol of American industrial capability, recognized in every corner of the world. The diesel engine became an increasingly central element of Caterpillar's business strategy during the post-war decades, as the company recognized that vertical integration of powertrain components offered both cost advantages and quality control benefits. Caterpillar began manufacturing its own diesel engines for its construction equipment in the 1930s and gradually expanded into engine sales for other applications, including marine propulsion, electric power generation, industrial pumping, and petroleum drilling. The 3400 series engine family, introduced in the 1970s, became one of the most successful industrial diesel engine platforms ever developed, powering everything from fishing boats to backup generators for hospitals. This engine business would eventually become the company's largest segment by revenue, reflecting the reality that Caterpillar was as much a power systems company as a construction equipment manufacturer. The engine division provided a natural hedge against the cyclicality of the construction market, as power generation and marine customers continued to buy engines even when building activity declined. This diversification was not the result of a grand strategic plan, but rather a pragmatic response to market opportunities. The labor relations history of Caterpillar is a study in the tensions between industrial efficiency and worker rights, and it reveals much about the changing nature of American manufacturing in the late 20th century. The UAW union represented Caterpillar workers for decades, and the company experienced a series of increasingly bitter labor disputes in the 1980s and 1990s as management sought to reduce costs, increase flexibility, and implement new production systems in response to intensifying global competition. The first major confrontation began with a 5-month strike in late 1991 involving approximately 12,000 workers, which ended in April 1992 when the company threatened to hire permanent replacements and the union ordered its members back to work without a ratified contract. A second, more devastating strike began in June 1994 and lasted 17 months, becoming one of the longest major strikes in modern American industrial history. The contract offer was ultimately voted down by 81% of the membership, but union leadership called off the strike in December 1995 regardless, and workers returned to their jobs under the company's terms. The conflict reflected the broader pressures facing American manufacturers as Japanese competitors like Komatsu eroded Caterpillar's market share, and the company needed to reduce production costs to remain competitive internationally. The resolution of these disputes involved significant changes to work rules, compensation structures, and production methods, and the experience permanently altered the relationship between the company and its workforce. The strikes demonstrated that even the most iconic American manufacturers were not immune to the forces of global economic competition. The rise of Komatsu as a global competitor in the 1980s forced Caterpillar to confront the limits of its traditional business model and undertake a comprehensive restructuring that touched every aspect of its operations. Komatsu's strategy was straightforward: target Caterpillar's most profitable product lines, undercut prices, and leverage lower Japanese labor costs to capture market share in North America. The rise of Komatsu as a global competitor in the 1980s forced Caterpillar to confront the limits of its traditional business model and undertake a comprehensive restructuring that touched every aspect of its operations. Komatsu's strategy was straightforward: target Caterpillar's most profitable product lines, undercut prices, and leverage lower Japanese labor costs to capture market share in North America and Europe. The response from Caterpillar under the leadership of CEO George Schaefer was to initiate a massive cost reduction program known internally as the Plant with a Future initiative, which involved factory automation, supply chain rationalization, and the implementation of just-in-time manufacturing techniques borrowed from Japanese practice. The company also accelerated its development of new products, particularly in the hydraulic excavator category, where Komatsu had been particularly strong. The competitive battle between Caterpillar and Komatsu became a case study in how established industrial leaders respond to disruptive challenges, and Caterpillar's survival and eventual recovery demonstrated the resilience of its brand, dealer network, and engineering capabilities. By the late 1990s, Caterpillar had regained its competitive position, though the market had been permanently transformed. The Caterpillar product line expanded dramatically during the 1990s and 2000s, both through internal development and strategic acquisitions that brought new capabilities into the company's portfolio. The acquisition of the German engine manufacturer Muck in 1997 strengthened Caterpillar's position in large marine and industrial engines. The purchase of Progress Rail in 2006 made Caterpillar a major supplier to the railroad industry, including the manufacture of diesel-electric locomotives that directly competed with long-established players like General Electric and EMD. The acquisitions of Bucyrus International in 2011 for $8.8 billion transformed Caterpillar into the dominant supplier of underground mining equipment, adding massive drag lines, roof bolters, and continuous miners to a product line that had previously focused on surface mining. Each acquisition was integrated into the Caterpillar dealer network and service infrastructure, creating a comprehensive equipment ecosystem that no competitor could match. This acquisition strategy reflected a deliberate decision to grow into adjacent markets rather than attempt to dominate existing ones through price competition alone. We should note that the Bucyrus acquisition, while strategically sound in its intent, occurred at the peak of the commodities supercycle and was followed by a sharp downturn in mining investment that significantly reduced the return on Caterpillar's investment. The mining downturn of 2012-2016 was severe, with mining companies cutting capital expenditures by over 50% and idling entire fleets of equipment worldwide. Caterpillar was forced to close plants, lay off thousands of workers, and write down the value of the Bucyrus acquisition by billions of dollars. This episode is a useful reminder that even the most well-managed industrial companies are subject to the brutal cyclicality of end markets that they cannot control. The company's response to the downturn, however, demonstrated the value of its diversified business model. The construction and power systems segments continued to generate cash flow that helped the company survive the mining recession without resorting to emergency measures. The recovery in mining markets after 2017 was slower than many analysts expected, and the experience permanently changed how Caterpillar manages its mining business. The company's approach to technology and innovation has evolved significantly in the 21st century, shifting from purely mechanical engineering to integrated digital systems that connect machines, operators, and fleet managers in real time. Caterpillar's Cat Connect system, introduced in the 2010s, uses telematics, sensors, and cloud-based analytics to monitor machine health, optimize fuel consumption, predict maintenance needs, and improve job site efficiency. The company has invested in autonomous vehicle technology, with autonomous mining trucks now operating in multiple sites around the world, hauling millions of tons of material without a human operator in the cab. These innovations represent a fundamental shift in the company's value proposition. Caterpillar is no longer merely selling iron, but is selling productivity, uptime, and operational intelligence. The transition from mechanical manufacturer to technology-enabled service provider has required changes in engineering talent, software development capabilities, and customer relationship management. It is not clear whether this digital transformation will ultimately prove as durable as the company's mechanical engineering heritage. The financial characteristics of Caterpillar as a publicly traded company have made it a bellwether for the global industrial economy, with its quarterly earnings reports analyzed as indicators of economic health across multiple sectors. Caterpillar's revenue cycle closely tracks global GDP growth, commodity prices, construction spending, and energy investment, making it one of the most economically sensitive large industrial companies in the world. The company's inclusion in the Dow Jones Industrial Average reflects its status as a proxy for industrial America, and its stock price has historically been highly correlated with investor expectations about global economic growth. The financial performance of Caterpillar's dealer network is itself a useful economic indicator, as dealers tend to order new equipment when they see sustained demand from end customers and cut orders sharply when they anticipate a downturn. Investors in Caterpillar must accept significant earnings volatility as a condition of ownership, and the company's share price has experienced drawdowns of over 50% during major recessions. The long-term returns to shareholders, however, have been substantial for those who held through the cycles, reflecting the company's fundamental competitive advantages. The environmental and regulatory challenges facing Caterpillar in the 21st century are among the most complex in the industrial sector, as the company's products are directly associated with carbon emissions, fossil fuel consumption, and the environmental impact of construction and mining. The company has responded with a multi-pronged strategy that includes the development of hybrid and electric powertrains for smaller equipment, the use of lower carbon fuels like natural gas in its engines, and the application of digital technologies to improve job site efficiency and reduce waste. Caterpillar's engines must comply with increasingly stringent emissions regulations in the United States, Europe, and other markets, requiring continuous investment in after-treatment systems, electronic controls, and combustion optimization. The company has also positioned itself as a supplier to the renewable energy sector, providing generator sets for solar and wind farm backup power, gas compression for biogas applications, and energy storage solutions. The tension between Caterpillar's traditional business of building diesel-powered machines and the global trend toward decarbonization will likely define the company's strategic direction for the next several decades. The outcome of this tension is uncertain and will depend on technological developments, regulatory decisions, and customer preferences that are still evolving. The company's cultural significance within American society extends far beyond its financial and industrial metrics, as Caterpillar's yellow machines have become visual shorthand for construction, progress, and American industrial might. The Caterpillar brand is one of the most recognized industrial trademarks in the world, and the distinctive yellow paint scheme, officially known as Caterpillar Yellow, is a protected trade dress that immediately identifies the equipment source even from a distance. For the audience that came of age in the post-war decades, Caterpillar equipment was a constant presence in the landscape, building the highways and suburbs and shopping centers that defined the physical environment of American life. The company's machines appear in countless films, television shows, and documentaries as symbols of work and construction. The brand's association with American strength and capability is so deeply embedded that it operates almost at the level of subconscious recognition. This cultural resonance is not the result of marketing campaigns, but of decades of physical presence in the American landscape. The Caterpillar Foundation, established in 1952, has surpassed $1 billion in philanthropic contributions across 110 countries since its founding, making it one of the most significant corporate foundations in the industrial sector. The foundation's focus areas include environmental sustainability, access to water and energy, and workforce development, reflecting the company's understanding that its long-term success depends on the health of the communities where it operates. The foundation has funded projects ranging from wetland restoration in Louisiana to vocational training programs in Africa to disaster relief efforts in the aftermath of hurricanes and earthquakes. The existence of the foundation and its activities are not widely known outside of professional philanthropic circles, but they represent a significant commitment to corporate social responsibility that is consistent with the company's long-term orientation. The effectiveness of these programs is difficult to measure with precision, but they have undoubtedly improved the company's relationship with governments and communities in many markets. The dealer network that Caterpillar built over the course of the 20th century remains one of its most durable competitive advantages, a distribution and service infrastructure that no competitor has been able to replicate. Caterpillar dealers are independently owned and operated businesses, typically run by families who have held the franchise for multiple generations, and they maintain inventories of parts, service facilities, and field service trucks that allow them to support equipment in even the most remote locations. The relationship between Caterpillar and its dealers is governed by a set of agreements and mutual expectations that have evolved over decades, and the company has historically been reluctant to terminate dealer relationships even when presented with more cost-effective alternatives. This loyalty to the dealer network has a cost, as independent dealers must earn a profit margin that vertically integrated distribution might avoid, but it also creates a level of customer service and local market knowledge that competitors cannot easily match. The dealer network is the distribution equivalent of Caterpillar's product engineering, invisible to most observers but fundamental to the company's success. The future of Caterpillar will be determined by the company's ability to navigate three simultaneous transitions that are reshaping the global industrial economy. The first transition is the shift from diesel power to alternative energy sources, including battery electric systems, hydrogen fuel cells, and sustainable biofuels, which will require fundamental redesign of virtually every product in the company's portfolio. The second transition is the integration of artificial intelligence and autonomy into construction and mining operations, which will transform the relationship between machine and operator and may eventually eliminate the operator entirely from certain applications. The third transition is the geographic shift of global infrastructure investment toward Asia, Africa, and Latin America, where the largest populations of new infrastructure consumers are located. Caterpillar's ability to manage these transitions while maintaining the quality, reliability, and dealer support that define its brand will determine whether the company continues to thrive or gradually declines into irrelevance. The company that began as a desperate merger of two competing California tractor manufacturers has become one of the most important industrial enterprises in the history of the United States, a machine built to build machines, an engine of American physical development. From the track mechanism that kept a tractor afloat in the California mud to the autonomous haul trucks that move ore in Australian mines, Caterpillar has consistently solved the hardest problems in moving earth. The yellow machines remain the most visible symbols of American industrial competence, and their enduring presence on construction sites around the world is a testament to engineering that works, service that supports, and a brand that represents something larger than the sum of its parts. The story of Caterpillar is the story of America building itself.